All right, friends, welcome back. In this video, I'd like to go ahead and talk about section 1.7 from your textbook, and this section talks all about linear inequalities in one variable. So let's get started with that. So when we talk about inequalities, what we're talking about are comparing numbers. And what I'd like to go ahead and cover first here is the difference between interval notation and inequality notation. So these are both ways that we can go ahead and describe certain subsets of the real number line. So just to remind you, when you are doing interval notation, this is the notation with the brackets and with the parentheses, and where we use symbols like positive or negative infinity depending on what our interval looks like. Okay, so in interval notation, if we do want to include the endpoint values, we are going to use a set of brackets. If we do not want to include the endpoint values, we're going to use a set of parentheses. And if our interval just races off to either positive or negative infinity, we're going to use the symbols for those. Okay, inequality notation is different because it's going to use those inequality symbols, right? So if you have either less than or equal to or greater than or equal to, then that means that we are including those endpoints. If you do not have the or equal tos, then that means that you are not including the endpoints. And this is not notation that uses the infinity or negative infinity symbols. Instead, what you're typically going to find is that we use the variable x to just represent the fact that we wish to talk about all the numbers that satisfy the given description. Okay? And so one of the first skills that we need to pick up here, or make sure that we have, is being able to translate between these two languages, right? So here I'm going to give you a bunch of examples that are all written in interval notation. We just have to go over really quickly how to write them in inequality notation. Okay? So a couple things I want you to call your attention to. First of all, I have a parenthesis on my -3, and I've got a square bracket here on my +5. So don't forget that that means that I'm not including -3, but I am including +5. And so when I go to my inequality way of writing this, I'm going to go ahead and write my x, which again is just my placeholder for all the numbers that are going to fit these descriptions. Okay. What I want is all the x's that are going to be greater than -3. And so I'm going to go ahead and set that up so that I'm saying -3 is less than x. But because I do want to include 5, and I want everything that is on the left side of 5 on the number line, I'm going to go ahead and say here x is going to be less than or equal to +5. Okay? And so that would be the way to go ahead and write this in inequality notation, keeping track of what I'm including and not including. And then the directions ask us to go ahead and state whether or not this interval is bounded, by saying that it's either bounded or unbounded. The idea with bounded is that it is an interval that has a definite beginning and a definite end, right? So if I were to actually go ahead and draw this on the number line, which I'll do here for a few examples, here's where 0 lives. I might just go ahead and say here, -3 is there, +5 is there, and a lot of the times when you see people drawing these graphs on the number line, you'll see them actually put the shading on the line itself, but I think it's a little bit more clear to go ahead and draw it above, right? So I am not including -3, so I'll put an open dot there. I am including +5, so I'll put a closed dot there, and I just want to go ahead and represent visually that I want everything in between, okay? And so that is a shaded region that has a definite beginning and a definite end. You might say that it has two bounds on it, so this would be a bounded interval. Basically, it's always going to be bounded unless you have an example that races off to either negative or positive infinity, okay? So as another example of that, maybe let's go ahead and take a look at part D down here, okay? So this is the open interval from -infinity to +12. So if I was going to write that using inequality notation, then I'd go ahead and start by writing my x down. And then what I want to convey here is that I want all of the numbers that are going to reach as far left of the number line as possible, so all of the negative numbers, and then going right on the number line all the way until we hit the number 12. So that would be the list of numbers that begins at 12, but then we just want everything less than it because we're racing off to negative infinity. So here I'd go ahead and represent that by saying x is less than +12, and of course that would be the the inequality way of writing it. If I was to draw a picture of that, then it would be really simple and straightforward. Here's where 0 lives. Maybe say here's where 12 lives. I am not including 12 in this description, so open dot, and I would want to shade everything to the left of that number because I race off to negative infinity here, okay? And so this would be an example of a interval that is unbounded because that will race off to negative infinity, Okay, it works the exact same way as if you had an interval that would race off to positive infinity there as well. So if you have either of the infinities in the mix, it's going to be unbounded, whereas if you have a definite beginning and a definite end, that is going to be bounded. I'm going to go ahead and skip those next two examples here just for the sake of time in the video, but if you have questions over those, feel free to let me know. The next slide here just talks about different properties of inequalities that we have, and I'm not going to dive too deeply into any one of these, but these are all the properties that are going to allow us to solve inequalities later in the video. So without getting too bogged down here, really the only one that I really want to call your attention to is maybe numbers 3 and 4, okay? So really number 3 is just going to go ahead and say here that I can add the same thing to both sides of an inequality and not lose any meaning, okay? So basically adding something to two sides of the inequality is a legal move in algebra, okay? And as far as rule 4 is concerned here, what this says is probably the most important rule when it comes to solving inequalities, and that is if you multiply or divide both sides of your inequality by a negative number, then the direction of your inequality is going to have to flip, okay? And so I want to go ahead and write that as a note here just so we understand that that's really what this rule is saying, and that's something we're going to have to keep in mind as we solve problems. So if you either multiply or divide, which I'll just abbreviate, by a negative number, which I'll represent here by just a negative sign with a circle around it, okay? If you multiply or divide both sides by a negative number, then your direction of your inequality is going to have to reverse directions, okay? So I'll say that by saying flip the direction of the inequality, which I'll just abbreviate that, okay, by saying inequal, okay? So again, that is probably the most important rule when it comes to solving inequalities that you could possibly write down is, again, if you ever have to do that in your problem-solving process, we're going to have to change the direction of your inequality. So a couple of straightforward linear inequalities here in one variable. Here is starting us off. We just have 5x minus 7 is greater than 3x plus 9. The most important thing, again, to remember is that rule that we just wrote down. So if we ever have to multiply or divide anything by a negative, then we are going to have to change the direction of our inequality, okay? So this one is pretty straightforwardly solved. I'm just going to go ahead and solve this as if it were a linear equation. So subtract 3x from both sides. We're going to get 2x minus 7 is greater than 9. And then after that, go ahead and add 7 to both sides. We are going to see here we end up getting 2x is greater than 16. And then, of course, we're going to divide both sides by 2. So really quickly done. Very straightforward here. X is going to be greater than 8. And so in the directions, it says to solve each inequality, which we just did, but then sketch the solution on a real number line, okay? And so this is our solution set written in inequality notation for us. And so we just need to go ahead and represent that on the number line itself, okay? So we'll go ahead and box that. Just for a short aside, right? We should go ahead and probably practice writing this in interval notation here as well. So if I want all the numbers that are greater than 8, then that is going to be the list that starts with 8 and then races off to positive infinity, okay? Infinity is always going to have a parenthesis around it because we'll never reach it, so we can't include it. And then also for 8, since I don't see the or equal to, I'll go ahead and include that with a open parenthesis there, okay? So that would be the inequality way of writing that interval or the interval way of writing that interval. Or there's the graph, which we'll go ahead and draw here right now very simply, okay? So whenever I draw a number line, folks, I always want to go ahead and mark where 0 is just so I have a point of reference. I'm going to turn my ink to shape off because it's playing tricks on me here. And then we'll go ahead and mark where 8 is. And, of course, we want to go ahead and shade all of the numbers that are strictly greater than 8. And so we'll go ahead and leave this as our final result there, okay? And so that is going to be a complete problem, right? So when you solve your inequality, make sure that you're able to write your solution set in both inequality and interval notation, and also be able to go ahead and provide a nice picture of the number line, okay? Part B is very, very similar here. We would just want to go ahead and start this off by clearing the fraction here in this problem, okay? Because again, we talked about this in a previous video, but here in this problem, we have this fraction with a divided by 2 in it, okay? And so what we want to do here to start us off is we want to go ahead and do something to everything here in the inequality that's going to get rid of a divided by 2, and of course that's going to be multiply everything by 2, okay? And we are going to go ahead and distribute that into everything. So if we do 2 times 1, of course it's going to give us 2. If we do 2 times the fraction 3x minus 2, of course the whole reason we introduced this is so that it would get rid of the divided by 2, so that just leaves us what was on top, which is 3x, and then that's greater than or equal to, and then distribute 2 to both of the other terms here. So we're going to be left with here 2x minus 8 as an equivalent form of the inequality that we started with, okay? And the rest of this gets solved very, very straightforwardly. We are just going to go ahead and add 3x to both sides to combine our x terms there. So we're going to end up with 2 is greater than or equal to 5x minus 8. And then after that, add 8 to both sides. So we are going to be left with here 10 is greater than or equal to 5x. And then finally, to finish us off here, we're going to divide both sides by 5. Keep in mind here, at no point are we ever doing a step that involves multiplying or dividing anything by a negative number, so the direction of my inequality symbol is going to remain the same, okay? Now, the result that we ended up here with is 2 is greater than or equal to x, which is the correct solution, but in general, we always like to write our final solution in inequality notation so that x comes first, and then we could say how x is related to the other number here. So the proper inequality notation that we would want to go ahead and write down here is x is less than 2. The interval way of writing that would be, of course, to say, since there are infinitely many numbers that are less than negative 2, it would just race off to negative infinity. We'll go ahead and say the open interval from negative infinity all the way up to 2, but we'll do a closed bracket there on 2 because we do wish to include that in our interval. Okay, so 2 different ways of writing that interval there, and then, of course, drawing the number line here. We'll do this up top where I've got some more room. Very, very simple and straightforward. We just have to go ahead and mark where 2 is. I always like to mark where 0 is. And then if I am including 2, I'm going to go ahead and use a closed dot there and then shade everything to the left of it, just to signify that that is racing off to negative infinity there. Okay? So, some pretty straightforward solutions, some pretty straightforward solvings of linear inequalities here. Here in the next slide, I'm going to go ahead and change the title of this slide because while it's not altogether incorrect to call these double inequalities, that's not really their technical name. So instead of calling these double inequalities, these are called compound inequalities. Okay? Much like you would have a compound sentence in English class, a compound sentence is a sentence that's made up of 2 sentences joined by a conjunction like and or but or something like that. In compound inequality is the same thing. It's 2 different mini inequalities conjoined by a conjunction, either and or whatever. Okay, and so they'll typically look like one of these. These are going to be examples of compound inequalities that are conjoined by the conjunction and, okay? And what I really want you to kind of hone in on here is the fact that you are looking at 2 inequalities for the price of 1, okay? So the first inequality that we can point out here is this one, that 0 is less than 3x minus 5, and the second inequality here is that 3x minus 5 is also less than or equal to positive 1. So this is 2 little mini inequalities for the price of 1 here, and this is just a way for us to go ahead and write down both of them. Okay, so we just want to solve this by saying whatever I do to one of my 3 sides, I have to do to the remaining 2. So if I add 5 to the middle column here, I'm going to have to also add 5 to everything else. So 0 plus 5 there is going to equal 5, and that is less than 3x, which is less than or equal to 1 plus 5, which makes 6. And then to solve this one up, we just have to simply divide everything by 3 here, okay? So again, these blue operations that I'm performing, nothing is going to make the direction of that inequality flip because I'm not multiplying or dividing anything by a negative there, okay? So in inequality notation, that is our interval right there. In interval notation, we would want to go ahead and say the open interval from -5 over thirds, positive, all the way until we hit 2, and because we do see the or equal to there on the 2, I'm going to go ahead and include that in a square bracket. So that would be the interval way of writing that region, okay? And then, of course, we want to go ahead and draw a nice picture of this. So if I draw my number line here really quick, okay, we just want to go ahead and signify here that I have 0 maybe right here. Here's where 5 over 3 would live. Maybe say here's where 2 would live. I do not wish to include 5 over 3, so open dot. I do wish to include 2, so close dot. And I do want to say I want to shade everything in between. So there would be the graphical way of representing that solution set right there. Okay. Here in the next one, same thing. We do see this big divided by 2, and so remember that the way that we get rid of that is by this process of clearing the fraction, which involves that we do the opposite of dividing by 2 to everything. We're going to multiply everything by 2. Okay, so if we start that off here, I keep trying to change colors, but OneNote doesn't like that. So here we go. All right. There we go. If we multiply everything in this inequality by 2, then we're going to get -10 where the -5 used to be. That's going to be less than or equal to just the expression 3 minus x, which is less than or equal to 4 times 2, which is 8, of course. Okay? And then after that, we would go ahead and get rid of this +3 by subtracting 3 from all 3 columns, and that's going to leave us with -13 is less than or equal to x, which is less than 5. And so not quite finished yet, because what we are left over with here, we need to be a little bit careful, is not just x, but a negative x, okay? And so to finish this one off, we would have to get rid of that negative, and the way we do that is by dividing everything by a -1, but here we are, right? We have a step here where we are dividing by a negative, so what we need to make sure that we do whenever we write our next step here is reverse the directions of these inequalities so that they point in the opposite direction, okay? So we're going to have x in the middle, and then positive 13 over here, and -5 here. And then just conventionally speaking, in the world of mathematics, we like to go ahead and write our inequality notation so that we are keeping the order, right? So the order of the number line, I mean. So negatives to the left, positives to the right. So I'm just going to go ahead and flip this around really quickly, and then you'll notice that my inequality signs are also going to flip direction as well. Okay, so whereas the or equal to was over here, now it's over here because it's attached to that 13, okay? If I were to go ahead and write this in interval notation, it'd be pretty simple. Just parenthesis on a -5, comma, with a 13 and a square bracket, okay? So you can kind of see why we might appreciate some interval notation because it takes less writing. And then, of course, drawing the number line here, very simple and straightforward here as well. We'll just write this really quick. Maybe say here's where 0 is, here's where -5 is. My goodness, ink to shape. And then here is where 13 is. I might say I am not including -5, but I am including positive 13. And in this one, I want to shade everything in between. So there is a bounded interval right there. Okay, so if you have a linear inequality, a compound inequality in this way, again, very simple, straightforward. Always keep in mind those special quirks about these problems, right? Okay, so we're going to get into some inequalities that involve some absolute values, and due to the definition of absolute value being the distance away from 0, we need to be careful about when we're saying the distance away from 0 is less than or greater than a number. So, in general, if you have an equation that looks like this right here, where it says you have the absolute value expression is specifically less than a number, then this is how we're going to go ahead and split it up to solve, okay? We are going to go ahead and substitute what we are given with this equation right here, okay? So whatever this number a is, we're going to go ahead and write the negative version of a and the positive version of a in one of these compound inequalities, okay? And so again, to help you remember this, think about this, right? Think less than, okay? So if you have a less than symbol, that is going to be an and problem. And what the graph is going to look like, of course, is here's negative a, here's positive a, and the graph, of course, would look like shading in between those two values, okay? So if that ever says less than, then that means that we are going to be shading in between our two values. Instead, if it instead says greater than in the problem, then that means that this is going to be an or inequality, okay? So we're looking here at the inequality symbol. If that is a greater than, then this is the way that we're going to go ahead and split it up right over here using the conjunction or instead of and like in the last one, okay? So the way that that's going to look like on the graph is, say, here's negative a, here's positive a. Instead of shading in between, we would go ahead and have two regions that would shade in reverse directions away from each other, okay? So one races off to negative infinity while the other races off to positive infinity. And just so that we're aware, this works the same way as if it had said or equal to in the problem as well. But this is just a way for you guys to go ahead and remember how to split these up. Think less than, and then if you have a greater than symbol, think greater, okay? So let's go ahead and take a look at that here, right? So a couple of examples dealing with absolute value inequalities. Here I'm definitely seeing that we have a less than symbol. So remember, that's less than. And so remember how we can go ahead and set this up. I'm just going to go ahead and take the expression in between the bars, and I'm going to say less than 2, but greater than -2. That's how we discussed how to split this up. And once you set this up for yourself, it's very, very easy to go through and do the steps to solve. We're just going to do the same things that we were doing before. -2 plus 9 is going to give us 7, and that is less than x, which is less than 2 plus 9, which is 11. Okay, so there is our solution set written in inequality notation. Really quickly, in interval notation, it would look like 7, comma 11. And then because I don't see any or equal tos, just two sets of parentheses, and that would be the same region, just in a different language. And then it does say to graph the solution, so just getting lots of practice with this in this video here. We might go ahead and draw ourselves a quick number line, and then go ahead and signify that maybe say here is 0, maybe here's 7, and here is 11. I do not want to include either of these two endpoints, but I do want to include everything in between them. So we'll go ahead and draw a quick picture of the number line in that way. Not too bad, okay? Here in the next example, it says the absolute value expression is greater than or equal to 7, so that's greater. So that means that we are going to go ahead and combine these two compound inequalities by the conjunction or, right? So what we're going to go ahead and do is we're going to look at the slide that came previously, and it is going to say that the way we want to split this up is by saying less than or equal to -7, and then separately greater than or equal to +7, okay? So the expression in between the bars is what we're going to go ahead and replace here on the other sides of these inequalities here. So x plus 3 and x plus 3, and that's going to be the setup here. And we're just going to go ahead and solve these two separately. So might say subtract 3 from both sides in both of these inequalities, and we would be simply left here with x is less than or equal to -10, or x is greater than or equal to +4, okay? And to write it using inequality notation would be something as simple as that right there. To write this in interval notation, anytime you have the word or, that would be using the union symbol whenever you write your inequality notation, right? So if you've never seen the union symbol before, it looks like a little capital letter U. But what we would want to do is go ahead and translate both of these inequalities into interval notation separately and then just conjoin them using this U symbol. So if x is less than or equal to -10, then that means that that's going to be the interval starting from -infinity on the number line all the way until we reach -10, parenthesis around -infinity because we'll never reach it, and then because I see the or equal to square bracket. On the other one, x is greater than or equal to 4. We'll go ahead and start that interval off at 4 with a square bracket to say that I am including it, and then since there are infinitely many numbers that are greater than or equal to 4, we'll just say that that races off to +infinity. And this would be the way that we would want to go ahead and represent that interval in interval notation. Okay, so wherever you see that word or, that's going to be your union symbol. All right, and then for the number line real quick, we'll just go ahead and draw our line, and we'll mark where 0 lives, and then say the following, right? We'll say that maybe here is -10, here is +4. I do wish to include both of these values, so solid dots on both of these values here. And then because it's an or, that means that they're going to shade away from each other, okay? So in other words, shade in the direction, just kind of translating what you wrote over here. If I want all the real numbers that are less than or equal to -10, I'm going to shade to the left. If I want all the real numbers that are greater than or equal to +4, I'm going to shade to the right. So there we go. In example 3 here, I want you to be a little bit careful because what might pay dividends here is from time to time just checking in with yourself and making sure that you know the definition of absolute value, right? So if you take the absolute value of anything, what you're really finding is that number's distance away from 0. So I'm going to solve this problem by just translating what it says here using symbols and math to just plain English, okay? So when I say the absolute value of this number, what I'm saying is that number's distance away from 0 is how we would translate that into English. And then there is our less than symbol, so I might just translate that to be the straightforward translation, less than, okay? Or I might say is less than, all right? And then finally, we've got our -5 here. So if you read this sentence in English, what are we really saying? We're saying the distance away from 0 is less than -5. Okay, and the reason that I'm doing this is because we need to kind of remember from geometry class that distances are never something that are allowed to be negative, okay? You don't measure things using negative numbers, you measure things using positive numbers. And so if we're set up here to say this in English, that the distance away from 0 is going to be less than a negative number, that's something that doesn't really make sense from the very beginning. And so our conclusion here would be simply say that we do not have a solution to this absolute value inequality, okay? Because distances can never be negative. So if you ever see the absolute value expression is less than a negative number, this is a conclusion that you can immediately go ahead and write down as your final conclusion. I'm going to go ahead and skip example 4 here in the video just for the sake of time. The only thing I do want to say about this is that you always want to isolate your absolute value expression before you split up, right? So here you'll see I have an extra -5 there on the left-hand side along with the absolute value expression. This is something I would really like to get by itself before we start splitting up here. So this is just an example of one that's going to have a first step before we continue on with the problem here. So I might go ahead and write this as the absolute value of 8 minus 5x on the left is greater than -2 plus 5. It's going to be 3, okay? And because that's a greater than symbol, that means greater. That means this is going to be an or problem. So I'm going to set this up and say 8 minus 5x is less than -3, or 8 minus 5x is greater than +3. And then you just want to go through and solve those really quickly. I'll just give away the punchline here. If you solve this first one, you're going to be dividing by a negative number, so the direction of your inequality is going to have to change, and you're going to end up with 11 over 5. Or if you solve this one over here, same thing, you're going to have to divide both sides by a negative, so the direction of your inequality is going to have to change. So we'll say x is less than positive 1, and that will complete the problem there. So there is your solution set written in inequality notation. I'm not going to bother doing the interval notation or the graph on this one because it would be straightforward according to the last examples. And then the last example I want to do in this video is example 5. It's an actual word problem here. So it says you are considering 2 job offers. The first job pays $3,000 per month, which I just might make a note of here. So job number 1 down here pays $3,000 per month. Okay, and then it says the second job pays $1,000 per month plus a commission of 4% of your gross sales. So I'll say over here, job number 2, that will pay you $1,000. And then in addition to that, plus it's going to pay you 4% of your gross sales. So if I go ahead and want 4%, I'm going to go ahead and write that as a decimal, 0.04. And then I just need something that's going to represent my gross sales. And so we'll just go ahead and say that that's X. So if I say 0.04X, that's me taking 4% of my gross sales here. Okay, so that's my second job. So it says, how much must you earn in gross sales for the second job to pay more per month than the first job? Okay, so we want whatever is over here on the second job to be greater than what is over there on the first job. Okay, so I might go ahead and put one of my inequality symbols there just to represent that idea, and you can see why I lumped this into your inequality notes here today. This is just something that you can go ahead and solve here by simply taking away $1,000 from both sides of this inequality, and that's going to leave us with $2,000 here on the left-hand side, which is less than 4% of my gross sales. And then in order to go ahead and figure this out, I would just simply go ahead and divide both sides by that value 0.04. Okay, and again, keep in mind at no point am I ever doing any operations that change the sign of numbers. I'm not multiplying or dividing by any negatives here, so I am free to go ahead and write down my final solution here, which is going to be $50,000. Or I should say, to be a little bit more clear, that X is greater than $50,000, okay? And so if we kind of interpret that within the context of the problem, after I restart OneNote because it just crashed on me, what that's going to mean is that your gross sales need to be something that is greater than $50,000 per month, okay? And so that would be the way that we would want to make our conclusion on a problem like that, okay? So that's it for this video. I hope that this has been of some help to you. If you guys have any questions, as always, feel free to let me know. But that's all I have for this one. Thank you very much for your attention, and I will speak to you in the next one.